Okay, so today we're going to look at different forms of linear relations. So we're going to find out that there are three sort of traditional forms of linear relationships. We've been working with the y equals mx plus b format the most rigorously. So that will be familiar to you, but the other two we'll just sort of introduce for future reference. Okay, so we have spent a lot of time working with this one, sometimes called the slope y-intercept, also called just the linear equation, y equals mx plus b. It's the one we use most often in grade 9 and 10. But just so we're clear, there are other forms. This one is called the intercept form, and we're going to utilize that today. And you'll notice the x and the y are on the left side and the whole numbers on the right-hand side. And then standard form will be usually saved for a little bit more in grade 11 and 12, because we'll be doing some other things with it, grade 12 in particular. But just so you understand, standard form has a 0 on one side. So they've moved all of the terms over to one side so that there's a 0. All of these can be rearranged and manipulated to create each other just using our algebra skills we've been working on. So our opposite operations, so we can move things around pretty quickly. So the equation of a line is given by the following. Now we've called this partial variation for quite a while. This is the equation of a line. It's what we use most in grade 9. And m is the slope and b is the y-intercept. So let's just do a quick refresher. If I have y equals 3 over 2x minus 5, then my slope is 3 over 2, and my y-intercept is 0, negative 5. And you want to get in the habit of writing those things down that way. So as soon as you see this form, write the information down so that you can utilize it. Write the slope, write the y-intercept in coordinate form, very important. Okay, so here's how we're going to use it. State the slope and y-intercept for the following and use that information to graph the line. Now, this is where we can get away from ever using tables of values again, because let's face it, trying to set up a table of values with this 3 over 4 as the multiplier starts to lead to a lot of fraction creation. And we can do this if we just go up by multiples of 4, but there's an easier way. So if you write down the slope is 3 over 4 and the y-intercept is 0, 5. You get those two pieces of information on the page, I give you marks. Okay, and now here's how we use it to graph. So watch how easy this is. I'm going to plot 0, 5, the y-intercept, so 1, 2, 3, 4, 5. Okay, so that point I know is on this line. Now I'm going to use my slope, which is 3 over 4, so that's up 3, right 4. So I'm going to go up 3, right 4, and put a dot. Okay, I know that point is also on the line. Now I could also work backwards. Instead of going up 3, right 4, I can go down 3 and left 4. And what we should notice is that they start to line up. Okay, so now if I've done this correctly, come on there, pencil, I get a line. Okay, so no table of values required. I just need those two pieces of information and I can draw this fairly quickly. Okay, so now let's look at the second one. My slope is negative 5 over 2 and my y-intercept is 0, negative 3. Now, I do want to slow down for 1 second here. This is negative 5 over 2, so I am expecting this graph to go down from left to right. And that's a really big idea we want to keep track of. So I'm going to plot my y-intercept first. 1, 2, 3. I put that 0, 3, negative 3 on there. Okay, now my slope is negative 5 over 2. So that means down 5, right 2. So 1, 2, 3, 4, 5, 1, 2. I put a dot. Okay, now again, I'm going to run out of space, so I'm going to work this backwards. So instead of down 5, right 2, I'm going to go up 5 and left 2. So up 5 and left 2. And what I should see is they form a nice straight line, as good as I can draw in here without a ruler. And again, no table of values required. So that's a pretty slick way of drawing lines. But the key is you have to be in this format. Okay, so here's the next strategy we're going to try. Okay, so now we have state the slope and y-intercept for the following and use that information to graph the line. But they're not in the right form. So this is where your algebra skills from the previous unit come into play. You have to manipulate and move this expression around until it looks like y equals mx plus b. Okay, so if you want to pause and try that, you're welcome. Okay, I'll just wait for you if you like. Okay, I'm going to carry on. I'm going to assume you've had a chance to try it. So I'm going to add 5x to both sides. I'm going to add 12 to both sides. So my new expression looks like this, where these guys have canceled and these guys have canceled. Now you might say, hey, your slope's 5 and your y-intercept is 12, and you would be wrong. Okay, and the reason you'd be wrong is that the y is not by itself. So you have to divide everything by 4, and then you would have it in the proper form. And we tend to leave these as fractions. The slope, just leave it as a fraction. It's so much easier to see rise and run. Okay, so now if you look here, you would have a slope value of 5 over 4 and a y-intercept of 0, 3. Okay, so now I would come over to my graph, I would plot 0, 3, I would go up to 4, 5 over 4, place a dot there, and then I would go back 4, down 5, and those 3 should line up nicely. There's my line, voila, I'm done. Okay, so again, if you want to pause it for a second and try the next one. Okay, so I need to rearrange, so I'm not going to write the steps in this time. I'm going to make you think about it. That would be where my first spot goes. So I need to get the 7x and the 16 to the other side. Then I'm going to divide everything by 4. And I get this really, really scary number of 7/4. And 16 divided by 4 is 4. Okay, so I've left out the steps there. I'm going to let you try that. So all I've done is adding, subtracting terms, dividing terms. You can figure that out. So now, the slope for this particular question is 7 over 4. The y-intercept is 0, -4. I'm going to choose a different color. Let's choose blue. So now, oops, I'm going to again start at 0, -4. There it is. Now, this is a positive slope of 7 over 4. So up, 2, 4, 7, right, 4. There is my dot. I got an extra one that sort of popped in there. Get rid of it. Okay, and now just in the interest of speed, I'm going to trust that for now. I would like to get a third one, but I also want to keep this video a little bit short. Okay, so that's all you need to do to graph a line without a table of values. You avoid all the fractions and everything, but I'm going to give one big suggestion though. Leave this as a fraction. Okay, it makes it way easier to see its rise over run. If you divide this out and you get 1.75, you're not going to know how to plot that. So leave your slopes as fractions. It makes them way easier to see. Okay, now this is a bit of a not a new concept. We did a little bit of this in chapter 4, but we're going to revisit it. I'm going to give it a little more structure. Okay, I want to find just the x-intercept and just the y-intercepts. And yes, you could rearrange the equation into y equals mx plus b to find the y-intercept. That would be totally okay, but we're going to do this in a slightly different way. And I'm going to ask you, beg you, plead with you, please write these titles down. They make a huge difference in explaining what you're doing. So if I want to find an x-intercept, that's where my line crosses the x-axis, I know the y value is 0. So what I can do is I can substitute in a y value of 0. So my expression now becomes negative 4x plus 4 times 0 is 0 minus 12 equals 0. Okay, so now what's important there is that y term has disappeared. It's gone. So now I just have to solve this expression. So I'm going to add 12 to both sides. So I can get that 12 to the other side. Okay, so now I have negative 6x equals 12. Divide both sides by negative 6. And I'm left with x equals negative 2. And I'm going to ask one favor. Please, please, please finish with a coordinate. So what you'll notice is here's the y value, here's the x value that make up that coordinate. Okay, that's really important from a communication standpoint. And now let's do the y-intercept. So now the y-intercept has an x value of 0. So if I put an x into here, negative 6 times 0 is 0. Okay, so I can even shortcut this a little quicker. I can just write 4y minus 12 equals 0. 4y equals 12. And you can ask yourself, how did that 12 jump to the other side? Well, we added 12 to both sides. Okay, I divide both sides by 4, and I get a y value of 3. And again, I'm going to take those two pieces of information. The x is 0, the y is 3. Okay, now if I plot those, 0, 3, and negative 2, 0, I have 2 points. That's enough to graph a line. It's not ideal, but it would look something like that. Okay, so please note that that is something you will be asked to do in a task, and you want the titles and you want these little y equals zeros and x equals zeros in there. Okay, find the x and y information for the following. So here's another example. It's in a bit of a different format. So pause it here and give it a whirl, and then I'll take it up. Okay, so here we go. X-intercepts, y equals 0. What's really nice about this method is that if you put that 0 in, a lot of the algebra simplifies quickly. So if I substitute y equals 0 in for there, negative 5 times 0 is 0. My new equation is this. Okay, that's a lot smaller, a lot easier. If I divide both sides by 10, I can get my x-intercept really quickly. It's negative 3. And if I bring those two pieces together, there's the coordinate. Negative 3, 0, bang, done. Okay, so you can, once you start to get the feel of this, the understanding, it goes really fast. Y-intercepts is x equals 0, so I'm going to put a 0 in on this side. So that becomes negative 5y minus 30 equals 0. Okay, so if we do a little rearranging, we're going to add 30 to both sides. Okay, I'm just going to do it up here in the same color. Those cancel, and then divide both sides by negative 5. We get y equals negative 6, and again I want to get those two pieces of information together to make my complete coordinate. 2, 4, negative 6, and then if I draw that line, I'm done. Okay, so that's a strategy you need to have. It's really important. If you try it a couple times, you'll see it's actually really fast. There's a couple questions to try, and thanks for tuning in.